Okay, so the marks, comments are all up for the database assignment. Sorry about being a bit of a, not being the best administrator when it came to the release of the pre-release of the comments and marks. Nothing actually changed, but now they've been moderated, so they've been checked. If you do want additional feedback, come talk to me during the practical, or arrange another time to talk to me if you want some additional feedback on that. They were generally okay, you know. There were a few that were a bit needed a bit more work, but basically if you did the work, you got a reasonable mark. Okay, so this week it's an introductory lecture on JavaScript, the DOM, which is the document object model, and PHP. And how I'm meant to teach you two programming languages in one lecture is quite beyond me, but that's what I'm going to attempt to do. But the idea of these lectures about code, as you know, are incredibly dull. And writing code is a practical thing. So the idea is really all we can do is give you a flavor of how to code rather than teaching you exactly how to code. So it's the kind of, that's all we can do, really. It's only a short period of time, can only do so much. Okay, so in the lectures today we'll cover JavaScript, pseudocode, which is it's really logical programming design. Pseudocode being one way of building a logical model for a program, the other one being just flow diagrams. We'll see those. A little bit on debugging. Debugging is the art, to me, debugging is the art of coding, really. If you can't debug, you can't code. So it's really important that you learn how to debug, and it's difficult, and it takes time to pick up. Then we'll see the document object model, basically how you can use, that's how we use JavaScript to manipulate and change the entries on a web page or in an XML document. Any document that we can get access to, XML-based document, we can use the document object model to manipulate that document. And finally, we'll meet PHP, the server-side language, PHP, that runs on Apache and other web servers, and see how we can combine JavaScript with PHP to create our AJAX interfaces. As I say, this is going to be an overview rather than giving you the minute details of how these are actually achieved, which is what's in the practical materials. So first thing is just a reminder or a little bit of a revision about programming languages and the fact that there are two different types of programming languages, and so far we've only seen declarative languages, or you've only actually played around with declarative languages. We are now moving on to imperative languages, or using a couple of these imperative languages. So a declarative language, just to remind ourselves, is a language that allows you to specify something, but not how that something is done. Yeah? So we've seen HTML. HTML specifies the content, and if you pre-CSS, or if we ignore CSS, the styling of a web page. It tells you tell the machine to have this content and style it in a particular manner. Then the computer program that reads that HTML actually decides how it goes about doing that. How does it put turn that HTML file into a page that it displays on the screen? And as you've probably experienced, different web browsers do it in a slightly different fashion, or support a slightly different set of functions. So I was just trying to complete early module feedbacks on SharePoint site 10 minutes before coming in over here for the lecture, and I discovered that the text boxes on the form when I was using it in Chrome didn't wrap the text, whereas they were wrapped in if I used Internet Explorer. So, as I say, HTML, they're both exactly the same HTML code. Each is producing a slightly different behavior because of the way that's incorporated by the software. Other declarative languages we've met, SQL. You declare the query that you wish to undertake. You throw it at the query engine, and the query engine deals with searching through the ordering of how to search through the tables, how to join them together to optimize the query. You're not telling it to join this table. You're not telling it how to join this table to this table. You're just telling it to do it. Yeah. Other ones, XML. XML just states data. It declares data, but it doesn't say anything about what you might do with that data. Same with JSON, same with KML. So those are declarative languages. Imperative languages, on the other hand, are what you would call normal programming languages. Programming languages where you tell the machine what to do and how to do it, or you tell it how to do it, and by following your instructions, it achieves, hopefully, what you want it to do. Okay? And examples of imperative languages are JavaScript, the browser-based language we're going to start programming in today, hopefully. The server-side language, PHP is an example, but also Java, C, Python, Perl, Visual Basic, whole hundreds and hundreds of these languages out there. Okay, so JavaScript. We know it's an imperative language that runs server-side in web browsers. It can also be run outside of web browsers in other environments, and you can write, I believe, whole programs in JavaScript. So while it's a web language that was developed specifically to make web pages dynamic and to give interactivity across the World Wide Web, it is now used elsewhere as well. I have never actually seen it used elsewhere, but you can use it. One thing to note is that it's called JavaScript, but it is completely unrelated to the programming language Java. I'm not quite sure exactly why they share the Java bit, but it has nothing to do with Java language. The code for JavaScript is defined on a server. So somebody writes that JavaScript code, just like you write your HTML page. It's declared server-side. And then when the web page is requested from the server by the client, not only is that web page, but also embedded JavaScript programs are also passed back to the client program. And there are a variety of ways that you can connect JavaScript with HTML, but it's primarily through these script tags. So you use a script tag, and then you can embed your JavaScript within a script tag within your HTML. We'll see these actually done. One of the primary uses of JavaScript is to interactively change and manipulate the contents of the web page that's being displayed through accessing the document object model. So it allows us to change the contents of headers, the colors, CSS. It allows us to interact with the CSS as well, so we can change both the design and the content of the page on the fly. JavaScript libraries, there's a whole variety of JavaScript libraries. One of the things that JavaScript libraries provide is advanced graphic capabilities that are not basically supported by HTML. So the web mapping interface leaflet is a JavaScript program. And many of the fancy graphics that you see on web pages are JavaScript, the result or the product of JavaScript programs. It's all relatively what we call lightweight language. After all, it has to be constantly, programs are being passed across the internet all the time. You don't want a heavy-duty language. You want something that can be compressed as much as possible. And as I've mentioned before, when we combine this with XML being produced by server-side program, that results in what we call this AJAX. in which we can make behind the scenes requests. So our web page can make a request to a server to get a little bit of data that comes back and allows us to update our web page. This leads to a more efficient exchange of information, data over the network. We exchange less information, and it also allows a smoother user experience because we're not constantly having to refresh the entire web page, just update the little bits of the web page that are linked with the change in data. JavaScript, right, okay, where do we code JavaScript? Okay, there are several places where we can code it. We can either put it within script tags that can be anywhere within the HTML file. They are often put in the header section because they're not part of the body content of the page, so that's often where they're put up at the top of the header file. However, sometimes you need to put them further down in the web page because you need the web page to have been read a certain amount. So you need the various HTML elements to have been uploaded into the browser before you can start manipulating them. Okay, so sometimes you need part of the web page to be loaded before you can run your script because the script accesses bits on the page. Sometimes people do things like you can set flags and things that say don't run this program until the web page is fully loaded. Anyway, getting your scripts and your web loading to synchronize and to work together can be slightly problematic. So just bear that in mind. If something is not working, if you can't see something in your code that you think you should be able to see, then it may be that you're calling the code before you've actually loaded the web objects up, the HTML objects up. Don't worry about that too much. So in the header, I could have a script tag, close my script tag, and in between those script tags, I can write JavaScript. This alert is just a command that will kick up one of those alert boxes. We'll see them in a minute with a bit of text in that says threshold must be an integer 0 to 100. So it's giving me some kind of feedback on some kind of entry perhaps that I've made in a field. Maybe it's a % I've got to enter, but I've entered a value that's too high. So you can write JavaScript directly in your HTML pages. And that works okay if you've got a small amount of JavaScript. It's fine. As soon as you've got any significant amount of JavaScript, the more code you have, the more unwieldy the files become. Also, you may want that code to be accessible from multiple web pages. So you want one page of code that's called by multiple pages. So I would recommend coding in an external JavaScript file. And in this case, we have an attribute. Our script tag has an attribute type, which equals JavaScript, text JavaScript. That tells us to expect a script in JavaScript. There are other types of languages that could be used here. I believe this is now optional in HTML5, and it just assumes if it doesn't have a type that it's JavaScript, but no harm to put that in there, text JavaScript. The important one, though, is the src. Remember src from img elements in HTML, image elements. It points to the file. In this case, I've got a JavaScript file called javascript.js, which is in the same directory as my web page. Okay, this src could be a web address to a web library, something like that. So those are basically the two places that we write JavaScript. So I'm going to try some interactive coding in JS Fiddle here, so this is going to be a novel thing for me. So we're going to start just with a really basic couple of rules of syntax. Lines of code should end with a semicolon. It may work without a semicolon, it may not work without a semicolon, but good practice, put a semicolon on, you're less likely to have a problem. Okay. Oops. Comments, always useful to know. Double slash to precede single comments, single line comments, slash star followed ended by star slash will give you a multi-line comment. Always comment your code so that you remember what your sections of code are doing. You come back even a week later and you may not, but for a bit of code that's several pages long, and you might have forgotten exactly what bits of code are doing. So it's always a good idea to comment your code, and we'll talk about that in a later lesson. Perhaps reserved words. Every language like SQL has a set of reserved words that do particular things. HTML has them as well. JavaScript has them as well. So avoid these names as variables, function names, and everything else. There's a long list online. This list is online, obviously. This is the W3 schools list. You know, some of them are pretty straight, evident. Don't use the names of data types. Don't use the other names that are import done. Just bear that in mind, that there are certain reserved words, JavaScript words. There are also words that are used in HTML and Windows, and these are also best avoided for variable names and file names. So here's another whole list of different words that are also best avoided as names of variables and of things like that. Okay, so variables. In JavaScript, everything is stored in a variable. In fact, that's true, I think, for just about all programming languages. A variable stores something. You define a variable with the first time you use it with the var keyword. And that, again, is optional. So you can just write my variable equals 5, and it creates a variable called my variable, named my variable, with the value that's storing the value 5. It's good practice, I think, to write var, because it shows you when you rewrite visit your code, or somebody else visits your code, where you first used that variable, and that's quite useful sometimes to know where that variable first appeared. Also, sometimes you want to declare variables as, oh, I haven't really gone into global variables and things. We'll have to have another section in another lecture on scope of variables and things like that, but I'll get to that in case. So you may want to declare a variable sometimes with global scope. I'll explain what scope is in another lecture. And then it's handy to have that list of variables that you know are declared at that level.
So
yep.
When you type var my variable, that means you don't have to type var anymore. You know it's that my variable.
Yeah. You use var to create a variable called my variable, but it is actually optional now. And if you just didn't put var in, then you would still create the variable. However, I think it's a good idea to, the first time you create a variable or where you define it, to use var, because it's just a clue, a mental clue, that when you look at the code you think, that's where that variable appears, and you know that it's not elsewhere further out in the code. So it's just a sort of organizational thing. Okay. So testing JavaScript out, or learning how to code in JavaScript, you can obviously code JavaScript in your HTML files. Then if you're on OSGeo Live, you can put those the HTML files with their linked JavaScript in your web directory, and then with the browser you can go localhost user and then run your HTML program, and it will run your JavaScript as well, and you can see how that works. And that's great. However, sometimes you just want to test and play around with code and just learn how a little bit of syntax operates. And then once you understand how that little bit of syntax operates, then you can incorporate what you've learnt into your actual files. So quite often it's useful to use these various there's a variety of these online. They're sort of, they're online code development environments. They have some limitations, but as I say, for just doing a little bit of testing out, they're quite a good idea. So this one's called JS Fiddle, and it got 4 different areas. As you can see, I can write some HTML code up in the HTML block. It automatically does the HTML tags, so you don't need those. I can declare some CSS in the top right-hand corner, and I can write some JavaScript in here. And then when I press run, I get the results in this box here. So here I've got a header, JavaScript example number 2. I've got an input box, an HTML input box of type text. That's there. And that I've got a submit button called change. And when that button is clicked, it fires the attribute called onClick here on this submit button. So when you press that button with your cursor, it fires the onClick event. In this case, the onClick event is calling a function called change, and I'll explain what functions are. I'm just explaining the interface here, the change. Here's the function change, and what it does is it adds, in this case, it finds the element, it finds the my text field element, which is this element, so it gets the value that's in this text box, and then it says, what does it do? If it's the length of, if the number of characters in this box is 0, then it returns a alert box that says write some real text, please. Otherwise, it gets the title and will update the title with the text that's in that box. Doesn't really matter what it does, but it's about where the interface is. Okay, so I'm just going to try.
So JS Fiddle, you don't need to link it. It's all, you can just pick the programming language you want to use. You don't need to link like CSS, HTML. It's just all one document.
It's all in one document, yeah. So here I am, okay? Here I am in JS Fiddle here. I've just got some code. I've got no HTML at all whatsoever. All I've got is var, my var equals 8. So I set my variable to the variable called my var to equal to 8. And then I'm going to produce an alert box which takes the value of my var and adds 10 to it. So when I run that, he says, oh, what's happening here? I probably haven't got an internet connection. Okay, let's wake the internet up. That's what it is. I've not got an internet. I don't have a Wi-Fi connection. So if I test run, come on. It'll probably take a moment to pick it up. Come on, I run that. There we go. So there's my alert box that's come out with the value 18. So I can change that, and I can go in, obviously, and I could just do my var equals my var plus 20, semicolon, run. Just doing its update there. Just a university computer doing its update all the time. Is there some reason? Oh, Mavar. Mavar, not my var, of course. Bug in the code. There we go. So it didn't run when my code was incorrect. So now I've got the value 38 because I've got 8. I add 20 to 8, 28, and then I add 10 to 28 to get 38. Okay, so good place to start learning a bit of JavaScript coding. Okay, let's go down. Okay. Inspect. Okay. One of the problems, so one of the ways that you can get feedback, to get feedback from your code, you can either make an alert box, which is quite handy, like I did before. So if I wanted a value, see what a value in my code, I get an alert box containing that value or some sort of text. Now that's all very well for debugging and working out what things are doing, but it's not very sensible for lots of other things. It's quite a sort of crass way of doing things. But if I want to find out what my variables are doing and report stuff to help find out what my program is doing, I can also use this command console.log, which will write the value of a variable out to what's called the console, and I can get to the console by using the inspect debugger that's supported by quite a few different browsers. So Chrome supports this, Firefox supports this as well. I don't know whether Explorer does as well. So if I go back to my JS thing, okay, so instead of having alert my var, what I'm going to do is I'm going to do console.log myvar.+10, okay? I'm going to run my command. Nothing seems to happen. I've no longer got an alert box coming up. But if I right-click and go to console, it opens up this development environment. This is embedded in what am I on now? Chrome. I think I'm running Chrome at the moment. But Firefox almost has an identical interface. Okay. And here I can see that the console log myvar.10 has output 38. If we click on the console section, console here, which will open the console window, I can see that the value of that variable is 38, and that allows me to test what the values of variables are. These errors up here, well, those were from my previous attempts on, so this isn't cleared. I can clear this window by pressing this little X there. So those were the previous ones when I misspelt myvar as mayvar. Okay. You can also, as you can see various bits of HTML. You can see the HTML code. You can see the JavaScript. Now, where this breaks down, or let's say Java, when you're using JS Fiddle, the response is when you open up the development inspect environment, what you see is JFiddle rather than your own environment. So while it's allowing me to at least print this out, and I can see the value, if I then click here to go and see the line of code that the problem, if I've got an error, if I've got one of these errors, I can click on there and I should be able to go to the line of code in the JavaScript or whatever that's causing the problem. But within the JFiddle environment, what you in fact is get a link that provides you with the code that's embedded within JFiddle environment. So it's not very good for that. That's what I'm trying to say. So if you want to do this and inspect, it's okay for us in JFiddle just to get the value of a variable, but you're much better working with your own code on Apache, not within JFiddle, to do the debugging, because it'll give you better links to the problems in your code, if that's understandable. Yeah. Okay. Right. So console log. There we are. Hello world, myvar, hello world. Oh yeah, syntax errors, yes. Watch out. If something is wrong, okay, look here, var, myvar equals hello world, console log myvar, and then I've got va, so I've missed the R off my var keyword there. So that's an error. It doesn't understand what va is. So it's kicked me out a syntax error, unexpected identifier. And as I say here, it's giving me a link to a virtual machine, line 45. That, if I click that, that gives me no useful information. Whereas if this was in my own code, when I click that, it would have taken me to the line. It would have told me line 3, which was the correct line for the error to have occurred on. OK. Variables. More on variables. Imperative languages come in two flavors in the way that they manage variables. There are what we call hard-typed languages. Let's see, what's a hard-typed language? C is a hard-typed language. Visual Basic is a hard-typed language. And in hard-typed languages, when you declare a variable, you also have to say what data type that variable stores. And that variable forevermore can only store that data type. So you declare something like var my variable as integer, and you can only ever store an integer in there, or as a string, and you can only ever store text in there. Soft, untyped languages are quite the opposite. You can change a variable name is just a pointer to some bit of something on disk, and you can have it as a string. So you can go var my variable equals cabbage as a string. It's now a string variable. I then, on the next line, I set it to an integer, and it's now become an integer. So in soft type languages, you can change what the type of object, the type of thing that's stored in the named variable anywhere in your code. Why do we bother with hard coding, typing and soft typing? Okay, just as an aside, hard typing is generally used in languages that are used in sort of what you could call strong, robust applications. Okay, that's the idea. If my variable is always an integer, when I try and compile my codes to make my program, I will get an error message kicked out if at some point I try and assign a value that is not an integer to that variable. And that is one way of error checking your code and making sure that your code is doing exactly what you want it to do. Okay, so it's a means of maintaining integrity across your code. Soft typing languages take the other approach. They say, you know, basically, we're not really interested, while it's good to end up with robust, strong code, we're more interested in facilitating people writing code rapidly. And one way to make things rapid, increase the rapidity of code development, is to not worry about the hard typing and defining variable store things. For example, if you had hard typing, you might need twice as many variables to be declared than you actually need, because you only need half that number of variables at any one particular time. Okay, it's a bit of a sort of artificial example, but you can end up using with a bigger program with hard type languages than you do with soft type languages, and they're slower to develop. So in this world of rapid software development, soft type languages are in many ways, I think that's one of the reasons why they're really popular. So Python is one, JavaScript is one, Perl is one. Whereas the hard type languages are maybe used for more sort of industrial strength software because they provide that extra level of robustness to your code. Something else to notice about variable names in JavaScript is that they're case sensitive. So capital H, hello, is different variable from lowercase hello. Two different variables. Given that we were a late start, I'll maybe just do another few minutes and then we'll have a break. And, okay, JavaScript supports many different data types. Numeric, text, Boolean, arrays, objects, there are many, many more. All data types, all variables, in fact, perhaps everything, I'm never quite sure whether it's quite everything, but everything as far as I'm concerned, anyway, in JavaScript, is an object. A variable is an object of a particular type, is a type of object. And as we know from last year, hopefully remember, objects are made up of properties, attributes, and methods, things that we can do to the object, things the object can do. And in JavaScript, methods are properties of an object that are defined as functions. We'll meet functions later on. Okay. We're not going to really learn a great deal about how to make objects, but we need to know how to manipulate them and use object methods and properties. So all data types are objects. In fact, everything just about in JavaScript is an object of some kind. And as it says here, the dot operator is used to access object attributes and methods. Now we'll see that in an example. So, user says, here's a string. String variable var user equals Bernie Sanders. It was last year when I was thinking about the election, and of course it's all hideously gone wrong now. Bernie Sanders. Okay, I can concatenate the string, put strings together to make one longer string with the plus sign. So I can go hello plus user plus nice to meet you. Notice the spaces being placed at the end of the words, because we're then going to fit in Bernie Saunders gets replaced for user. And then if I want to know how long that string is, I can use the length method on the variable. The variable is of a type string. Oh, it's user.length. All right, so user.length. So here's the variable user. The user variable is of type object string. Yep, it's an object type. It's a type of string object. That the string data type object supports a method called length. And when I call that method, that returns the length of that variable. So just really quickly, I mean, I can't repeat myself here, but never mind. It's always fun to play with a bit of code. OK, so console log, if I do myvar dot length, not surprisingly, we should get run, undefined, myvar dot. Oh, because it's a integer. OK, my value, so myvar equals David. Take that one off. Run that one. There we go. 5 characters in David. There we go. OK, so that's strings. Substrings, we'll just work our way through strings. So I think this is much in common with all languages, including SQL, if you looked at some of the string functions in SQL. So strings are indexed by each character starting at 0. So in this case, my user is storing Hillary Clinton. I can use the character at method to revert with an integer to return the character at that index. So character at 0 is the first character in the string. Character position 0 returns H. If I want to get the last character, I can do user character at. Then I get the length of the string and subtract 1 to get the last character, N. And if I want to extract a string substring, a set of string characters in the middle of a thing, the middle of the string, then I can use the substring method. And I can say start at the 4th character number 4, 1, 2, 3, 4, and return the next back 3 characters. So they're the 4th one, the 5th one, and the 6th one. So that gives me la, or return la. Basic maths, much just to say, is quite common. So I can set an integer value or a numeric value. Just set n equals to 100. If I want to add 10 into it, I just plus 10. If I want to increment by just 1, I can do plus plus n, and that will just increment the value of n by 1. So this is 110 now, goes up to 111. The minus minus n, it decreases by 1, so that becomes 110 again. I can multiply with a star, it's just standard stuff, 220. And we use the parentheses to define the order of operations in maths, just as we do in just about everything else in life. Maths functions. So as there are only a few operators defined in JavaScript. And if we want to do some more complex maths, we have to use the maths object. So there's a special object called maths, which provides support for a whole load of common maths functions. So here, I've got n equals 100. I've set my value to n equals to 100. And if I want to know the sign, as in the trigonomic function sign, of x, I have to use the maths object dot sign method, and then I put in the value x. And that will return me the sign of x. If I want the minimum of a string of numbers, a set of numbers, I use maths.min, and then I can put in my list of numbers, and I'll get the minimum value. If I want to round the value, I use maths.round, and I can stick the value in. And if I want a random number, I can use maths.random.
So there's extra variable there in the sign.
So here, x, it doesn't matter what x is. I've probably put n, it was probably... Yeah. So x maybe equals whatever the arc sign. That's poor, but yeah. Say x is 20, and 20 as in 20 degrees, and if I want the sine of 20 degrees, then I do math sine x, and in this case store that value in this variable. Let's have a break. 10 past? Yeah, excellent, and then we'll carry on with these functions.